Today we're going to take a look at arithmetic sequences. Sequences are an ordered list of numbers. So this would be an example of a sequence because the numbers are getting larger as the sequence continues. So it's ordered. Now, each of these individual numbers in this sequence is called a term. And each term has a specific position in the sequence. So this is our first term. So we call this A subscript 1. Our second term is A subscript 2. Our third term is A subscript 3. And it continues on and on and on. An unknown farther along term we call A subscript n. In an arithmetic sequence, what we always have is an ordered list of numbers in which the difference between each pair of consecutive terms is the same. So we can see in this sequence that all of the consecutive terms are increasing by a common difference. Each time I go from one term to the next, I'm adding 5. So I have a common difference between each consecutive term. So the common difference of an arithmetic sequence is the difference between each pair of consecutive terms. So in this case, it's plus 5. That's our common difference. So in an arithmetic sequence, the difference between each pair of consecutive terms is the same. That difference is called the common difference, and each term is found by adding the common difference to the previous term. So here they want us to extend this arithmetic sequence by finding the next 3 terms. So I've created a small chart here. The first number in the sequence was -7, the second -14, the third -21, and the fourth -28. And they want us to find the next 3 terms. So I notice here that each term is actually going down. So I'm adding a negative number, and it happens to be that I'm adding between these two -7. So I try it for my next two. I add -7, and I do in fact get -21. So I'm adding -7 each time. So I'm going to continue on with that pattern of adding -7. So that means that -28 plus -7, I'm going to get -35. -35 plus -7, -42. And -42 plus -7, -49. To graph a sequence, we're going to let the term's position, first, second, third, fourth, be our x value, and we're going to let the actual term be our y value. So in this case, in this sequence, it went 4, 8, 12, 16. So 4 is my first term, 8 is my second, 12 is my third, and 16 is my fourth. So I'm going to graph them as ordered pairs. So my first number in the sequence was 4. That's going to become the point 1, 4. The second number in my sequence was 8. That's going to become 2, 8. My third number was 12, so 3, 12. And my fourth number was 16. And they're asking us what we notice here. And what we should notice is these points are in a line. So if I wanted to connect them, they would be in a straight line. So we can use this to actually help us identify arithmetic sequences. So when I see them on a graph, I can always transfer them into a table, which is what I've done here, and see if they're in a line. These look like they're in a line. I'm going to double check by making sure that I can find a common difference here. So it looks like each time the number's going down, so I'm adding -3 here. I want to make sure that's consistent the whole way across. And it does work. So in this case, they're asking me, is this an arithmetic sequence? Yes, this is an arithmetic sequence with a common difference. With a common difference of -3. So take a look here. These guys don't quite appear to be in a straight line, but I'm going to put them in a chart and check. I notice here I'm going up by 2, but my next one I notice I'm going up by 3, then I'm going up by 4. So this is not an arithmetic sequence. I don't have a common difference here, so not an arithmetic sequence. So we can take arithmetic sequences and write an equation for them. So to find any specific term in an arithmetic sequence, any term, a to the subscript n, I need to know what the first term in the sequence is, that first term. And after the first term, to get to the next term, I'm adding a common difference. And then to get to the next term, I'm adding that common difference again. So this is my common difference. And I will add it to the terms, however many terms this is, -1, because it's not added to the first term. So let's actually try this out and see how it works. So they want us to write an equation for the nth term. I don't know what it is. They're calling it the nth term. And the sequence currently is 14, 11, 8, 5, and so on. Once we write that equation, they then want us to find the 50th term. There's got to be an easier way to do it than listing out 50 terms. I don't want to have to do that. So let's write our equation first. So a subscript n stands for a term of any number in the sequence. We start with 14. And we're going to figure out that number in the sequence we want, -1, that's going to be multiplied by our common difference. Well, every time here, we're going down by 3, so our common difference is -3. So I'm going to simplify this a little bit. I'm going to distribute my -3. So I'm going to have 14 plus -3n plus 3. And I can combine my 14 and 3 here. I'm going to have -3n plus 17. So here is my final equation here. To find a subscript n, any term, I'm going to take the term, multiply it by -3, and add 17. So we're going to actually try this with the 50th term. So if I want to find the 50th term, for n, I'm going to plug in 50. It'd be -3 times 50 plus 17. So -3 times 50 gives me -150. Now I have to do plus 17 and I get -133. So the 50th term in this sequence, if I kept it going, would be -133.